So we're starting a new unit called writing linear equations. And so what we've been doing is we've been given a linear equation in slope-intercept form, and we've been doing a lot of graphing using that equation. So now we're going to be given information, and our goal is going to be to write the equation in slope-intercept form. And we're really going to do that in three situations today. One is if we're just given all the information that we need. One is if we're given 2 points, although one of those points is going to have to be the y-intercept. And then the other one that's going to be similar is if it's just written using function notation. So let's recall that slope-intercept form is y equals mx plus b. And so the two key pieces of information when something is written in this form is the slope, which is always our coefficient of x, and the y-intercept, which is where it crosses the y-axis, and that's the number that's being added or subtracted. Remember, we always write it as plus because this value could be negative. So your task when you're doing this is to fill in these two missing boxes. We're going to want to know the slope, and we're going to want to know the y-intercept. Once you have these two pieces of information, you can just plug them into these boxes, and you've got a linear equation. So in the first situation, we're going to find that we have all of the information that we need. We have both our slope and our y-intercept. So all we have to do is plug those numbers into the boxes. And so, for example, my first equation, linear equation, would be y equals negative 2x plus 5. So I've put my slope as my coefficient of x, and I've put my y-intercept as the number being added in this case because it's positive. Pause the video, try examples 2 through 6. Be sure your answer is in the simplest form possible. Press play when you're ready to check your answers. So for example 2, I've got a slope of 8 and a y-intercept of negative 7. It's also possible to write anytime you see a minus, if you have it as plus negative, that would be fine as well. But the cleanest version would be y equals 8x minus 7. For example 3, y equals 4x minus 3. And for example 4, y equals 3/4 x minus 3. Now in examples 5 and 6, we've got a little bit something different going on because here I have a slope of 0. So it's possible that you started your equation by saying y equals 0x plus 5, which is definitely true. My slope is my coefficient of x, but remember that anything times 0 is going to be 0, and so then 0 plus 5 would simplify to just y equals 5. So we're going to write that. Also, we know that when it's just y equals a number, that's a horizontal line, and a horizontal line has a slope of 0. And then on example 6, again, you might have started by saying y equals maybe negative 1x plus 0, but since it's plus 0, we don't really even need it, and then negative 1x can just simplify to negative x. So the cleanest version of this equation would be y equals negative 1x. On situation 2, you'll see that we have information that's slightly different. So instead of being told the slope and the y-intercept, we're being told 2 points that are on the line. So the first thing I want to look at is what's the first key piece of information that's missing? And so the first thing that we're missing is the slope. And how can I use this information to find that missing information? And so what I can do is I can use the subtraction fraction, or the slope formula, m equals y2 minus y1 over x2 minus x1. So that's going to be the first thing that I'm going to accomplish, is finding the slope. The second thing I want to see is that my 2 points, one of them is special, and it's this one right here, because this point, since it has an x-coordinate of 0, I know that if I were to graph this point on my graph, I would not go over right or left at all, and I would just go down 5, which means that this point is actually my y-intercept. So I know my y-intercept. It wasn't as explicit as it was up here, but I still have it, and I'm able to find the slope using the subtraction fraction. And so over here, I just noted that the point that's in 0, b format is my y-intercept. Now remember, my goal is to fill both of those boxes. And so, but before I can do that, I'm missing my slope, so I'm going to do subtraction fraction. And so y2 would be negative 1 minus y1, which is negative 5, over x2, which is 3, minus x1, which is 0. And then I would do keep change opposite, and I would get 4/3. So I'm now able to fill my slope box with 4/3, and I know that my y-intercept is negative 5 for a final answer of y equals 4/3 x minus 5. So at this point, you're going to try examples 8 and 9 on your own, and also example 10. But on example 10, so we still have 2 points that are on the line, but they're not written in coordinate format, they're actually on the graph. And so instead of using the subtraction fraction to find your slope, you can use rise and run, and then you should also be able to just point to the y-intercept and identify it. Pause the video, press play when you're ready to check your answers for examples 8 through 10. On example 8, we were going to have a slope of negative 3/4, and of course our y-intercept is 2 since it's paired with 0, so y equals negative 3/4 x plus 2. On example 9, we had a slope of negative 1/2, don't forget to reduce, and the y-intercept is 1 since it's the number paired with 0 for an equation of y equals negative 1/2 x plus 1. And then on example 10, I've got a rise of 4, a run of 3, but my slope is decreasing, so it's a slope of negative 4/3. And then my y-intercept is the point at which it crosses the y-axis, and so that would be 3. Now keep in mind, you can also only do this when you know with certainty that your line is crossing at an exact integer coordinate. And tomorrow we'll figure out what to do if that's not occurring. So our final answer for this one is y equals negative 4/3 x plus 3. And the disclaimer says don't graph your points this large. Normally we graph a little more precisely, but I wanted you to be able to see those points. Now in situation 3, it's actually just like situation 2, it's just that the information is given to you in function notation. So remember that function notation is fx equals y. And so before we begin, we just need to put these in xy format. And so the number inside the parentheses is going to be our x value, and the number that the function equals is going to be our y value. So in example 11, my two ordered pairs would be 0, 5, and 4, 17. So I can still use subtraction fraction to find my slope, and I still have my y-intercept because for right now I'm still going to have an x-coordinate of 0. And again, we're going to build upon this and figure out what happens if one of your x-coordinates is not 0. That'll be in a future set of notes. So for this one, I would do 17 minus 5 over 4 minus 0, which is going to get me 12 over 4, which means that my slope is 3. And so then my equation would be y equals 3x plus 5. So it's just, again, going to be important that your first step on examples 12 through 14 is to create your ordered pairs first. Pause the video, try examples 12 through 14, press play when you're ready to check your answers. So on example 12, my two ordered pairs are 0, negative 2, and 8, 4. So 4 minus negative 2 became 6. 8 minus 0 was 8 for a simplified slope of 3/4, and my y-intercept was negative 2. So y equals 3/4 x minus 2. On example 13, my ordered pairs are negative 3, 6, and 0, 5. 5 minus 6 is negative 1, and 0 minus negative 3 is 3 for a slope of negative 1/3, and my y-intercept is 5. Remember, it's the one that's paired with 0, kind of like a little curveball here because that ordered pair just happened to come second. And then on example 14, our ordered pairs are 0, 7, and 3, 1. 1 minus 7 is negative 6, 3 minus 0 is 3 for a slope of negative 2, and a y-intercept of 7 for an equation of y equals negative 2x plus 7. We've just got two quick word problems. We've actually been working a lot with word problems like this, so this shouldn't be too new. Our real-world connection is that slope is going to be our constant rate of change, and our y-intercept is going to be our initial or our starting value. So in our recording studio, it says that it charges musicians an initial fee of $50 to record the album. So since that's my initial fee, that's going to be my B value. And studio time costs an additional $35 per hour. And one thing I want to notice in here is that it's actually has the word per. Remember, per is a word that means multiply, and I know that in my slope-intercept equation, my slope is my multiplier. So that's going to be my slope, that's my constant rate of change. And so my equation would be y equals 35x plus 50, and that's assuming that x would be my number of hours and y would be my total cost. It's important to identify those variables so people know what they represent if they're not already identified for you. And so now to use that equation, we could find the total cost, our y value, for an album that takes 10 hours to record by replacing x with 10 and doing out this math. And so I would get 350 plus 50 means that my total cost would be $400. So at this point, you're going to pause the video, try word problem 2, plus press play when you're ready to check your answer. And so in this case, our initial fee was the $20, and then our $25 per hour. That per is kind of like a little hint that that's going to be our constant rate because per is our multiplier. So 25 is going to be my slope for an equation of y equals 25x plus 20. And I actually forgot to identify my variables where x is the number of hours and y is the total cost. And so then I can use that to find the total cost for 2 hours of instruction by replacing x, which is my number of hours, with 2. 25 times 2 is 50, plus 20 is 70, and so it would cost $70 to have 2 hours of dance instruction.